Okay, time for a little bit of graphing. We're going to take our trig functions and graph them. What I'm going to do is I'm going to graph them in radian mode. These graphs could be done exactly the same if they were from negative 360 to 360. They would look the same. Okay, you'll see what would be different though. So the first graph we're going to graph is y equals sine x. Okay, very quickly, let's look at a couple of things on for sine x, and we're just going to look at the really basic points here. All right, at 0 radians, what is sine? Sine is 0. At pi by 2 radians, what is sine? Sine is 1. Remember, this is cosine, and this is sine. Okay, at pi, we've got sine is 0 again. At 3 pi by 2, sine is negative 1. So let's put those points on a graph. All right, and what we're going to do is here we're going to say this is theta. So we're going to go from 0 to pi by 2 to pi, 3 pi by 2, and 2 pi. That would be one rotation, and then we're also going to go negative. And so this is the graph from negative 2 pi all the way to 2 pi. Okay, and let's fill those values in. This value is going to be y, or in other words, it's going to be sine of theta. And you can see that the biggest value we have is 1, and the smallest value we have is negative 1. So, looking at our points, if we look here, at 0 radians, sine is 0. So that's going to be this point right here. At pi by 2, sine is 1. At pi, sine is 0. 3 pi by 2, sine is negative 1. And at 2 pi, it's 0. Okay? Now we're going to try to graph this. I mean, we could go and put some more values in here. You could figure out what is pi by 6. You could do pi by 4, pi by 3. We could figure out all those values, but we don't need to. So without finding all of those other points, we can draw a curve that looks like this. If we draw a smooth curve, it's going to look something like that. And I'm going to put an arrow there because it keeps going. In fact, it also comes into the negative. At negative pi by 2, you can see that sine is negative 1. At negative pi, sine is 0. At negative 3 pi over 2, it's 1. And then back to 0. And so this graph looks like this. And in fact, this graph continues on forever in both directions. Okay, let's take a look at some of the characteristics. What is the domain of this graph? Well, the domain we were just given was negative 2 pi to 2 pi. But the regular sine graph is negative infinity to infinity. The range is from negative 1 to 1. The period, okay, this is something new. The period is how long it takes for the graph to repeat. Okay? So the period is how far the graph moves to until it repeats itself. So if you look at this graph, and let's just start at the beginning here. Here we have a graph at 0 increasing. When does this happen again? Well, if you move along here, it hits 0 here, but it's decreasing. And then we move along some more. Here's where it hits 0 again and increases. So the period is 2 pi. Okay, the amplitude is how high or how much above or below the graph from the midpoint does it go. And if you can see in this graph, the midline is the x-axis, and it'll go up 1 unit and it goes down 1 unit. So this is our amplitude, 1. The zeros are the x-intercepts. And where do they happen? They happen at 0, at pi, at 2 pi, etc. So the easiest way to say that is to say k pi, where k is an integer. All right, k pi, because if k were 0, we would have 0. If k were 1, we would have just pi. If k were 2, we would have 2 pi, etc., 3 pi, etc., etc. Okay, equations of the asymptotes. Well, there are none. Where is this graph positive? Well, where is sine positive? Sine is positive in quadrant 1 and 2. It's negative in quadrant 3 and 4. And I've never seen this asked, where is the graph increasing or decreasing? But if you look at the graph, and we remember that we always read left to right, where is this graph going up? Well, you can see it goes up right here. Okay, and then it goes down here, and then it goes back up here. So it's increasing in quadrants 1 and 4 and decreasing in quadrants 2 and 3. Okay, why do I say quadrant 1 and 4? Well, right here we have the graph between 0 and pi by 2. And if you look up here, that's quadrant 1. All right, there's our sine graph. Let's go to the next graph, the cos graph. We're going to do the same thing. So we have 0, we have pi by 2, we have pi, 3 pi by 2, and then 2 pi. And if we look at the values, we have 1, 0, 0, 1, negative 1, 0, 0, negative 1. So plotting, I think on the last graph I said this was theta. We should actually say it's x though, because if you look at the graph, we're doing y equals cos x. So that's going to be x, and this is going to be cos of x. Or if you prefer, we can just call this y. Okay, so let's try it. We'll put a little bit of our intervals here. This is pi by 2, this is pi, this is 3 pi by 2, this is 2 pi. And I'm only going to do the positive here. Instead of going from negative 2 pi, I'm going to go just from 0, because usually we're just asked for one period. Okay, so at 0, cosine is 1. At pi by 2, cosine is 0. At pi, cosine is negative 1. And at 3 pi by 2, 0. And then back to 2 pi, we have 1. And so this graph is going to look actually very similar to the other graph, just kind of shifted over, because if you continue this, you're going to get that same wave. Okay? So let's look at the characteristics here. What's the domain? Again, negative infinity to infinity, and the range is still negative 1 to 1. Okay? What is the period? Where does this graph repeat? Well, if we start here, because that's where 0 is, it starts going down. Where does it go to 1 again and going down? Right here. So again, our graph is a period of 2 pi. The amplitude is still 1 because it goes up 1, down 1. Where are the zeros? Well, the zeros are every pi by 2. So how am I going to say that? I'm going to say pi by 2 plus k pi. Okay, now you're probably going to, you would probably see that in your textbook added together with common denominators. You don't need to. Equation of the asymptotes, there are none. Where is cosine positive? Quadrant 1 and 4. Where is it negative? Quadrant 2 and 3. Where is this cosine graph increasing? Right here. This is quadrant 3 and 4. Which means it's decreasing in quadrant 1 and 2. All right, that's the cosine graph. Let's do one more. We'll do the tan graph. Okay. So if we have our radians, 0, pi by 2, pi, 3 pi by 2, 2 pi, and if I remember the values, they're 1, 0, 0, 1, negative 1, 0, 0, negative 1. Now what is tan? Well, tan is always sine over cos. So tan of 0 is going to be 0. Tan of pi by 2 is 1 over 0, which is undefined. Okay, tan at pi, 0 divided by negative 1, that's going to be 0. Here we're going to get tan of pi by 2 is going to be undefined again. So how do we graph undefined? Well, we've seen that before. Undefined turns out to be a vertical asymptote. So there will be a vertical asymptote at pi by 2, at 3 pi by 2, and in fact there will be one every pi by 2. Okay, and then if we go to 0, tan is 0, at pi tan is 0, and at 2 pi tan is 0. Well, I don't know, that doesn't look like a lot to graph. I mean, what are we supposed to do? Draw something like this? Well, you should know that you can't go past the vertical asymptote, so that has to be asymptotic behavior there. What we have to do is figure out what's going on. It might be useful for us to go and think about pi by 4. What's tan there? And what is tan at 3 pi by 4, and 5 pi by 4, and 7 pi by 4? Well, if pi by 4 is right in the middle here, tan is 1. At 3 pi by 4, tan is negative 1. At 5 pi by 4, tan is positive 1. And at 7 pi by 4, tan is negative 1. Okay, so how to draw this? Well, it's a little bit confusing. Let's look just in between pi by 2 and 3 pi by 2. I can see that I want to go through these 3 points. But what happens when I get past this point? Do I go up like this and approach the asymptote, or do I go down like this and approach the asymptote? Okay, well, the graph actually looks something like this. And it's actually got kind of a cubic wave in there. Okay, and I'm going to draw it over here too, and over here too. That's not a very good one. Okay, so it's supposed to have this shape. Okay, and then you can see that here it's approaching the asymptote, here it's approaching the asymptote. Okay, what is the domain? Well, the domain is negative infinity to infinity, except x can't be what? Can't be where the asymptotes are. And that's at every pi by 2. X can't be pi by 2 plus k pi. The range, negative infinity to infinity. The period. How often does this graph repeat itself? It repeats itself every pi. The amplitude, there is no amplitude because it's not a wave, right? The other graphs are a wave like this. Okay, where are there zeros? The zeros are on every pi. The equations of the asymptotes are exactly where the domain doesn't exist. So that's going to be, oh, it's an equation, I better write. X equals pi by 2 plus k pi. That's a trick. Make sure if it says equation, you put the equal sign. Where's tan positive? tan is positive in quadrant 1 and 3, negative in quadrant 2 and 4. Where is tan increasing? Well, if you look at this graph and you look left to right, it's always getting bigger. So increasing everywhere. Decreasing nowhere. All right. So, your homework. You need to memorize these three graphs. Okay? You need to be able to graph sine, cos, and tan. And you need to be able to do it really well, because that's the rest of the unit, is we're going to be graphing that with transformations on it. Okay?